Now what if we're raising our division to a negative exponent? Here we have 3/4 raised to the negative 2. Well, I can still distribute this negative 2 to both the numerator and the denominator. So this would look like 3 to the minus 2 over 4 to the minus 2. And whenever you have a negative exponent, that means this is going to go in the denominator. So this 3 to the minus 2 is going to go in the denominator. And this 4 to the minus 2, well, it's already in the denominator, but since it has a negative exponent, we're going to move it back up to the numerator. So this is going to turn into 4 squared divided by 3 squared. So what we've done here is basically change this 2 into a positive and then take our division here and use the reciprocal. This is the same as 4/3 squared. So let's try this again. We have 7 divided by 5 to the negative 3rd power. Well, the first step then would be to change this negative into a positive and find the reciprocal of 7/5. If we do that, this will simplify into 5/7 to the positive 3rd power. Because when we move these to the negative and then switch them, we end up with just our reciprocal. This will further simplify into 5 to the 3rd over 7 to the 3rd. Now what happens if we have a power to a power? Here we have 4 cubed divided by 5 squared, all to the negative 4th power. Well, we can still change this into a positive and take the reciprocal of this. So this will change into 5 squared over 4 cubed, all raised to the positive 4th power. Now we'll distribute this 4 inside, so we'll take the power to a power, and this will become 5 to the 2 times 4 power divided by 4 to the 3 times 4 power. This will further simplify into 5 to the 8th over 4 to the 12th. And again, the same thing happens when we have variables. Here we have a negative 2 exponent on the outside of x times y divided by 4wz cubed. Well, right away we can take the reciprocal of this. That will be 4wz cubed divided by xy. And now this would be raised to the positive 2 power, or squared. Now we'll distribute this squared power inside. So we'll have 4wz cubed squared divided by xy squared. And then the square goes to each variable and number inside the parentheses. So this will become 4 squared times w to the 1 times 2 power times z to the 3 times 2 power. And that's divided by x to the 1 times 2 power times y to the 1 times 2 power. This will further simplify. Well, 4 squared is 16. W to the 1 times 2 power is just w squared. Z to the 3 times 2 power is z to the 6th. This is divided by x to the 1 times 2 power, or x squared, and y to the 1 times 2 power, or y squared. So our final simplified expression then would be 16w squared z to the 6th divided by x squared times y squared. Now lastly, we can use these division properties of exponents to solve things with very large numbers that are in scientific notation. Now we can use these division properties of exponents to solve large numbers that are written in scientific notation. Here we're told that the average distance from the Earth to the Moon is 1.3 times 10 to the 9th feet. The speed of light is approximately 9.8 times 10 to the 8th feet per second. So how long did it take the light reflected by the Moon to reach the Earth? Well, to figure that out, we're going to take 1.3 times 10 to the 9th feet and divide it by 9.8 times 10 to the 8th feet per second. Now if we do that, we can take 1.3 and divide it by 9.8, which will be 0.133. And this is going to be multiplied by 10 to the 9th divided by 10 to the 8th. Well, here we have the same base with different exponents, so we're going to subtract our exponents. So this is going to be 0.133 times 10 to the 9 minus 8, or 0.133 times 10 to the 1st. If we multiply 0.133 times 10, or 10 to the 1st, we'll just get 1.33. So it takes 1.33 seconds, approximately, for the light reflected by the moon to reach Earth. And that completes the tutorial on division properties of exponents.